Today I want to show you how to build this pulse motor with a chip scan rotor. Let's start with the rotor. I will use a chip scan. We need to make holes at the exact center of the lid and also of the bottom. Finding the exact center is not easy, but the lid has a mark and we will drill the hole there. Once you make the hole in the lid, put it over the bottom of the can and use it as a guide to drill the new hole at the bottom. The next step is to put an axle through the holes, which is nothing more than a straight wire. You also need to glue 4 neodymium magnets at 90 degrees from each other. It is important that they are placed with the same polarity. All faces are north or all south, but they have to be the same. If you were careful drilling the holes and placing the magnets, you will end up with a well-balanced rotor. The rotor rests on a wooden base that has these supports made of a wood stick, and the axis has these little beds. The outer ones are glued to the axis and the inner ones can move freely. In this way, the rotor can move without colliding with the wood sticks. We also need a coil to propel the rotor. This is made with magnet wire gauge 29 AWG. It is wound on a plastic bobbin for sewing machines. I will use the magnetic switch from this drawer light. As you can see, the light goes on and off when we move this little magnet inside this part. When it is closed, the switch opens and closes when we move it away from the lamp. Here you can see the magnetic switch. It is just a pair of metallic contacts inside a glass envelope. The magnet moves the contacts and makes the switching. With the coil and the magnetic switch, the motor is ready. So let's see the circuit. Here we put the battery or power supply, so the current comes here through the coil and from the coil through this wire to the magnetic switch. Then passes through the normal switch and then back to the battery. This motor needs very low current. Actually, it works pretty well with a AAA battery. It also runs happily with this little button cell. I have connected the motor to my variable power supply to show you that the motor can run from a voltage as low as 0.25 volts. How the motor works is very simple. When one of the magnets is close to the magnetic switch, the switch closes and the coil is energized. Then it pulls the magnet that is below and the rotor turns. Then the magnet is away from the switch and opens. Then the coil is not energized, but the rotor continues to rotate because of its inertia. Then another magnet gets close to the switch and the coil is energized again, pulling the next magnet. And this continues every quarter of a turn, and the motor rotates continuously.